last type of chemical durability that is there, and that is the alkali aggregate reaction, right? So when we talk about alkali aggregate reaction also, again, one fundamental phenomena that you need to always keep in mind that is associated with the durability of the concrete is that if the concrete is going to be permeable in nature, then only all kind of, it is going to be porous and permeable in nature, then all kind of these problems are going to be started. So if proper compaction and curing is done at the initial stage, and it is ensured that the permeability is low, and at the same time the concrete is non-porous in nature, then all these types of issues can be avoided, right? So, and again the same is that the typical nature of the different types of chemical durability that we have seen so far is that everywhere there is a chemical reaction taking place, then as a result of the byproduct that is formed from out of this chemical reaction, it increases the volume of the mix. Due to this increase in the volume, the pressure is exerted on the surrounding concrete surface, and as a result of that, the cracking and the spalling, and then the deterioration of concrete takes. So in case of alkali aggregate reaction also, there is nothing much different that is there. In case of alkali aggregate reaction also, same kind of thing happens. That is, the gel is formed, and due to this formation of this gel, the volume of the mix is increased, and as a result of that, the issues are present, right? So, but however, if we first look at how the alkali aggregate reaction is initiated or what are the sources, then in that case, again, just like in case of sulfate, we talked about the presence of sulfate in soil and water. Similarly, here also, there are two basic materials, or two basic elements in which the chemical reaction is taking place, and as a result of which the alkali aggregate reaction is initiated. That is the chemical reaction between the aggregates containing reactive constituents and alkalis, along with the presence of what we can say the hydroxyl ions that are released from the hydration of cement will result in the formation of alkali aggregate reaction. When you talk about these alkalis, then the alkalis are in the form of potassium and sodium in the cement content itself. So if this potassium and cement are going to be beyond a certain limit, then in that case the promotion of alkali aggregate reaction is very likely to take, right? So alkali aggregate reaction is a reaction which occurs over time in concrete between the highly alkaline cement paste and the reactive non-crystalline or the amorphous silica which is found in the many common aggregates. So if you talk about this amorphous aggregate or the amorphous silica that is found in the aggregate, then the example that we can take is regarding the granite, then quartz and the sandstone are the general sources in which the amorphous silica is likely to be present, right? So if we look at the sequence in which this alkali silica reaction takes place, then basically first of all the presence of alkali is going to be there, then presence of reactive silica is also likely to be needed, and along with that the moisture content is also, right? So if we talk about the presence of alkali, then presence of alkali will be from the cement phase. Then if we talk about the reactive silica, then that is going to be from the aggregates that we are selecting. And lastly, presence of moisture, then it is going to be related to the water cement ratio that you are having, and at the same time whether the concrete is porous and permeable in nature or not. So when all these three conditions will be acting jointly, then as a result of that a reactive gel will be formed, which is going to have, which is going to increase the volume of the cement paste or increase the volume of the mix to a great extent. And when this will happen, then as a result of that, it will try to make space for itself by breaking the intermolecular bonding between particles. And if it is not able to make place, then it is going to exert pressure on the surrounding elements, and as a result of that, the premature cracking in the concrete will take place, and as a result of that, the spalling will happen, and then the delamination of the concrete surface is also likely to take. Right? So now the question that comes to our mind is, why is it important for us to understand the alkali aggregate reaction? Why it is important? Because it is going to have a severe effect on the strength of the structure. Along with that, it is going to affect the stiffness of the structure, and also at the same time, it is going to break the impermeability of the concrete structure. So it is going to have effect on strength, it is going to have effect on the stiffness, and it is going to affect the permeability also, right? And at the same time, what is going to happen is that due to this external pressure that is generated, and due to which the cracking and spalling takes place, as a result of that, premature failure of concrete is likely, right? So that is why it is important for us to understand this process very clearly so that we can avoid these type of failures in the structure. And this behavior, when it will happen, then it will have an impact on the environmental and economic aspect also. How? Because due to the premature failure, you will have to go for reconstruction of that particular. And when you go for reconstruction, then you can see that the cost of cement is already high in the market. At the same time, it is not good for the environment also. That is, high consumption of cement is also not good for the environment. because as we know that 7% of the total carbon dioxide gas that is produced is contributed by the cement production that is taking place all around the world, right? So if we want to have a greener environment, then in that case we need to ensure that we avoid the initiation of alkali aggregate reaction in form, right? And now if you look at the sources, that what are the different sources through which this alkali aggregate reaction is initiated, then the primary source is going to be the alkalis. And if you talk about alkalis, then in that case basically two types of alkalis are present in the cement itself, that is sodium, that is Na2 plus, and potassium, that is K plus. Both of these are things are present in the cement by default, right? So if it is going to beyond a certain limit, then in that case it is going to be the source of alkali aggregate reaction that is. And what are the other sources of alkalis? Then it can be said that along with Portland cement, de-icing soils, and seawater. These are also primary sources through which the what you can say the alkali are going to be present. And if they are used, then in that case it is going to have detrimental effect on the solution. And at the same time, if you remember, we are using the term as amorphous or crystalline, non-crystalline or crystalline, right? So the structure of crystalline and non-crystalline or the amorphous is shown over, and you can see the difference between both the things, right? And as a result of that, you can see that it is easier to break through to the amorphous structure as compared to that of the crystalline. Now, just like in case of sulfate attack, we have seen certain patterns of failure. So similarly here also in case of alkali aggregate reaction also, you can see small maps of cracks that are there. So it is going to be concentrated maps of cracks that are going to be there in a certain amount of region. So if this type of pattern you are seeing on the surface of the concrete, then you can get a preliminary idea that the possible reason of this type of thing to happening is the alkali aggregate reaction that is taking. Now the question that comes is how to control ASR, that is alkali silica reaction. Now as I've said at the starting of the lecture is that the source itself is going to be the pure over here. That is, if you are able to control the presence of alkali, then automatically the things will be under control. If you are able to control the permeability of the concrete or water cement ratio, then automatically things are going to be under control. So same thing is mentioned over here also. That is, avoid high alkali content. So how avoid alkali content can be? That is, you need to make sure that the percentage of alkali present in the cement that you are using is not beyond the permissible value that is mentioned by the IS, right? So if you are selecting that type of a cement, then automatically you are taking the necessary precaution at the very initial. Then you can, other cause is the other major cause or major source of alkali silica reaction is the use of reactive aggregates. So if you are going to select aggregates which are going to be non-reactive in nature, right? So automatically, or which are non-reactive, we can also say inert, right? So if you are going to use aggregates which are having inert minerals or inert elements, then as a result of that, the reaction is not going to take place in the first go, and as a result of that, the reaction can be over. Along with that, if we have control over the excess of water, that is low water cement ratio is there, permeability of the water is also maintained, the curing condition is also taken into consideration depending upon the surrounding atmospheric condition, and suitable measures are taken for curing condition, then as a result of that, the transfer of moisture movement is controlled, and as a result of that, the alkali silica reaction can be averted, right? So these are all different sources through which, or different sources through which you can control the alkali aggregate reaction. And lastly, the reaction, that is the chemical reaction that is taking place in ASR, is also mentioned over here. That is CaOH twice, H2SiSO4, and the reaction is there in front of you, as a result of which the ASR, that is alkali silicate reaction in concrete is mentioned. And along with that, the crack that is found due to this formation of alkali silicate reaction is also there, and the core sample of the concrete surface which is affected by the alkali selected reaction is also shown to you on the screen over here, which is the yellow color image that is there. So you can see how aggressive it can become over a period of time if proper care is not taken. And it is but obvious that if something is detrimental to such a level, then as a result of that, it is going to reduce the service life of the structure, and as a result of that, the durability of the structure is going to be compromised to a greater, right? So it is very important for us to understand the aspect or the concept of durability of the concrete, and the five factors that we have discussed regarding the durability, that is the concrete cover, then compaction, then permeability, then cement type, right? These four factors are very important to in controlling the durability. So if we are able to focus on these four parameters at the very initial level, then all these chemical effects of durability that we have discussed over this entire series can be controlled to a great extent. I hope you have enjoyed today's lecture. Stay tuned for the further lecture series.